Now we're going to try to incorporate all of the different translations into a single sine or cosine function. This example is a cosine. We have an amplitude change, we've got some phase shift and period changes on the inside here, and we have a vertical shift on the outside. So really all of these different aspects that we've been talking about, except reflection. I don't have a reflection on this one, but that's okay. Okay, so the first thing is just to identify the four different translations that we have, or transformations that we have. The first is the, we'll go with the vertical shift. And the vertical shift, remember, is any constant that's added or subtracted on the outside of the cosine. Well, my cosine function here has the half times the cosine. That's not part, none of that is part of the vertical shift. Vertical shift is this -1 that's being added to it, okay? Sometimes we'll write that constant at the end, sometimes we'll write it at the beginning. So the position of it doesn't really matter because we're adding you can interchange or switch to the order. So it doesn't really matter where, if this was 1/2 cosine of all this stuff -1, it would be the same thing. It would be a vertical shift of -1. Okay, so the vertical shift in this case will be -1, or you could say down 1. Okay. We're just kind of working our way outside in for a moment. The next thing I'll look at is the amplitude. Okay, the amplitude is always the absolute value of the constant multiplying the cosine. Okay, so in this case it's the 1/2. Of course, it is always an absolute value. In this case, the absolute value doesn't really make a difference because the constant there multiplying it is already positive. Okay, so that's our amplitude. Then we'll look at the inside here. Remember, the inside, in order to identify our phase shift and our period, we have to factor this. So I'm going to take 2x minus 3 pi and write it in a factored form. Remember, the factors have to be a constant and then two terms where the first term is simply an x. So I have to pull out the coefficient of x, the 2, and then the second term is going to be whatever 3 pi divided by that 2 is. Well, it's 3 pi over 2. Remember, if this is a constant or an integer out front, you can pull out the integer and divide by it. If it's a fraction, division is equivalent to multiplying by a reciprocal. So we would, if that was like a 2/3, we would multiply by the reciprocal there, which we don't have to here. Okay, so this tells us that the constant that we factored out is going to factor into our period. The period, remember, is 2 pi over, we call it b usually, 2 pi over b, b being that constant, and so that's 2 pi over 2 in this case. The 2's would cancel, and we'd be left with just pi. One thing to keep in mind too, is kind of interesting, if you just had the cosine of x, the period is 2 pi. When you multiply by this 2, essentially what you're doing is you're putting 2 periods in the same 2 pi distance. Okay, so this gives you the number of periods that fits in 2 pi. Well, if 2 periods fits in 2 pi now, then 1 period would fit in half of that, which is pi. Okay, so that's where this kind of comes from. Another way to look at it. Also, then the phase shift. The phase shift is going to be this constant that's being subtracted. Remember, it has to be whatever's being subtracted there on the inside after the factoring is done. So that would be a 3 pi over 2 phase shift. Okay, so that gives us a summary of all the 4 pieces of information that we need to identify in order to plot the graph. once we've identified those, we need to get our 5 key points and then go through and plot the points. The 5 key points, let's get those figured out. Well, we always start, remember, at the phase shift. Okay, so that's where we shift off of 0. So the 5 key points will start at, I'll even draw a number line just so I can keep this straight. 3 pi over 2. And then 1, 2, 3, 4. We need the other 4 key points. We know that the period is pi, right? So I need to take the period divided by 4 to give me the jump to the next point. So the period over 4 is pi over 4. And so that's what we're going to add to each endpoint as we go to get the next. Okay, so we look at 3 pi over 2 plus pi over 4. Well, I need a common denominator, and that common denominator will be 4. So we have to multiply top and bottom by 2. That will give us, let's see, 6 pi over 4 plus pi over 4 is 7 pi over 4. Right, that will be, oops, I just hit that. That will be the second of the 5 key points. Next will be, we got to add pi over 4 to 7 pi over 4. That would be 8 pi over 4. And of course, 8 pi over 4 reduces to 2 pi, right? 8 over 4 is 2, so that's 2 pi. Then I take 2 pi and add another pi over 4. Well, I'm going to actually go with the 8 pi over 4, the unreduced form, because I need that common denominator of 4 anyway. So 8 pi over 4 plus another pi over 4 would be 9 pi over 4. So that's going to be my next point. 9 pi over 4. And then finally, the last one, I'm going to take the 9 pi over 4, add another pi over 4. We'll do this over here. And we'll get 10 pi over 4. And of course, that reduces, they're both divisible by 2. That would be 5 pi over 2. All right, so that gives us our 5 key points. We can always double check, and I always like to do this just to make sure I didn't make a mistake. I know the total period should be pi. So if I subtract the right end from the left end, I should get pi. So let's just double check that. Yeah. No, actually, let's check it. I'm going to save that spot for my graph. So let's check it up here. So the check is going to be 5 pi over 2 minus 3 pi over 2. And of course, they have common denominator. 5 pi minus 3 pi is going to be 2 pi. And 2 pi over 2, the 2's cancel, and you get pi, which was the original period, so that worked out. We didn't make any mistakes there, okay? All right, so next step is to plot the graph using our 5 key points and the resulting, the vertical shift and the amplitude factored in as well. So, let's see, I'm going to put my axes in red and I'll plot the graph in blue. So my axes here, I know my x-axis is going to be, these are all nice, positive values, so I don't need much on the left. I'm only going to do 1 period, but again, if you needed more periods, you can just keep adding the pi over 4 or subtracting the pi over 4 to get those. So here's my y-axis, and we'll get the x-axis in as well. Now the x-axis I put a little bit high on here because I know that my vertical shift is down, so I want a little bit extra space below the x-axis. fix this a little bit, have a little wobble in there. I think that's better. Okay, and so now the first thing I really want to do is get my units on the x-axis down. To do that, I'm kind of looking at these values here, my 5 key points, and I'm noticing lots of halves and quarters of pi. And so I know that 5 pi over 2 is actually 10 pi over 4. So if I do my units in quarters, I only need 10 markings to get up to 10 pi over 4 to get to the last of the 5 key points. I might actually go a little bit beyond that. Maybe I'll go to 12 pi over 4, which reduces to 3 pi. That way I have a little bit of a buffer on each end, make sure I get my graph in, and it looks kind of nice. So we'll go all the way out here towards the end, and I'm going to write in 12 pi over 4. Now, you guys will recognize this as I put my markings in here. A lot of these fractions are going to reduce. In my mind, I'm kind of thinking ahead here. I'm going to write out all the unreduced forms because I'll be able to keep track of them easier, all with pi over 4s, and then reduce them and put them above. And that'll give me a little more space underneath. I'll erase the ones that were unreduced when I'm done. So I've got 12 pi over 4 in the end. Cut this in half, and I'll have 6 pi over 4. And then cut in half here. This will be 3 pi over 4. Cut this one in half, and that's 9 pi over 4. So that gives me 4 of them. 1, 2, 3, 4, yep. And then I can fill in each of these. I'm going to need 2 more markings because I've got from 0 to 3 and then 3 to 6. So these are multiples of 3. So I need 2 more markings to get the other 2. So this would be pi over 4 and 2 pi over 4. And then chop that off again. That's going to be 4 pi over 4 and 5 pi over 4. And then I've already got 6. The next one will be 7 and 8. And then we'll have 10 and 11. So here's 7 and 8. And then we'll have 10 and 11. Okay, and that gives me 12 markings, right? 12 tick marks. Now, a lot of those are going to simplify, but not all of them. In fact, all of the odd multiples of pi over 4 will not simplify, right? Pi over 4, 3 pi over 4, 5 pi over 4, those will not simplify. So I'm just going to move those immediately up to the top. Could have done that right away, but didn't think that far ahead. So we'll do that. We'll move those up. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4, and 11 pi over 4. All right, so I've got those moved. Erase those. Okay, and now I've got all my even multiples of pi over 4, which do reduce. So I'm going to reduce them as I move them up. So 2 pi over 4 reduces to pi over 2. 4 pi over 4 reduces to just pi. 6 pi over 4 is 3 pi over 2. 8 pi over 4 is, 2 pi. 10 pi over 4 is 5 pi over 2. And 12 pi over 4 is 3 pi. Okay? All right, so let me clean that up just a little bit. Okay, looks good. Now, I get my y-axis in there. The y-axis, I know the vertical shift is -1 and the amplitude is 1/2. Now I use those two facts together to help me get my scale in the y direction. I know that with a drop of -1, but then the amplitude being 1/2 means from -1 you're going to go up 1/2 and down 1/2 to get the max and the min points. So that would be -1/2 to -3/2. Okay, that would be my region there. So I'm going to go, let's do -1, -2, and then my halves are going to be in between those, and I can run those across. And then, we'd have 1 up on top there, but we're not going to need all that. So let's see, let's run these across parallel to the x-axis. Then here at -1/2. Oh. And then down here at -3/2. Okay, so that looks pretty good. I've got my central axis here at -1, and then my maxes and my mins at -1/2 and -3/2. Okay, so then I can put my points in. Got a little bit of a wobble there I don't like. Okay, that's better. I can put my points in, 5 key points, and remember the cosine always starts high, right? Unless it's reflected. This one has no reflection on it because it's positive with the amplitude there. So there's no reflection, so we can start high, drop down, and then come back up. Okay, so generally speaking, the cosine graph has that shape over one period, okay? So we're just gonna use that shape and move it over. So in my 5 key points, at the first one, 3π/2, we start high. That's the high point is gonna be at -1/2. So 3π/2, where is that? Way over here, and -1/2. So that's my first point. Second point is gonna be at 7π/4, and that's where it's gonna come down and hit the central axis. 7π/4 gets right there. So it's gonna be a little narrower than I was hoping. That's okay. At 2π, you're gonna be at the minimum. That's a halfway point, right? Halfway point, cosine dips to the minimum. Then at 9π/4, it's back up to the middle axis there. Okay, and then at 5π/2, it's going to be back up to the maximum. 5π/2. There we go. All right, so you can see the 5 key points are plotted. Now I just got to get my curve to go through them nicely. And this is quite steep, so it's, yeah, but that works. It's not going to be quite as exaggerated of a curve as I like, but that works. It's not too bad. Okay. So there's my 5 key points. That's one wavelength of the cosine. Now, of course, if I wanted to continue that on, I already have the units broken down into quarters, basically. And we know that π/4 was the gap between the 5 key points. So I could just continue this graph on if I wanted to. Say at 11π/4, it would be at the midpoint, and at 3π, it's all the way down to the bottom again. And so we could continue this on if we wanted to the right, and we could continue it on to the left as well. At 5π/4 would be back down to the middle, pi would be down to the bottom, and then 3π/4 would be back up to the middle, π/2 up to the top, π/4 to the bottom, or to the middle again, and then at 0 would be down to the bottom. So we could plot this all the way back as many periods as we need. Okay, so that works out kind of nice that way. So there you go. That's that actually gives me 1, 2, that would be 3 full periods is what I plotted here, right? From minimum to minimum, 1, 2, 3 full periods of the graph. So that's kind of nice. I wasn't planning to do all that, but it works out well, and now you can kind of see how that would develop if you needed to extend the graph from one period to multiple periods. You know, something else that's kind of interesting about this as I'm thinking about it is that this graph, I'm sorry, this function is not the only function that plots out this graph, kind of interestingly. We could have used a different function here to graph out the same graph, which is kind of interesting. Let me show you that real quick before we move on to the next example or the next topic. I was just kind of thinking about it. What if I wanted to, instead of shifting this down to 3 pi over 2, what if I want the same graph starting at 0 with no phase shift? I could do that because the graph is at a minimum here. Well, remember, cosine starts at a minimum if you reflect it. And so that would give you a negative on the amplitude. The vertical shift isn't going to change, so you could use the equation -1 minus 1/2. That gives you a reflection, so you start at a minimum, and then do the cosine. And then because we're not doing a phase shift, I wouldn't have to do this minus 3 pi thing. I would just have the 2x. The 2 is still important because in the normal period of 2 pi, you're getting 2 wavelengths, so you still need the 2x in there. And so this equation actually gives you the exact same graph as this equation. Okay, so here you have no phase shift, but a vertical reflection. Here you have no vertical reflection, but a phase shift. It's kind of interesting, they give you the exact same graph. I think in the next video, what I want you to do, what I'm going to have you guys do is to actually create equations based upon the graph that's given, which is a little bit different, so flip and rolls a little bit here.